We as humans have accomplished incredible things. We have invented a society that rewards cooperation, found ways to eradicate horrible diseases, and even left the confines of our planet to venture into space. It seems like the new era, the Anthropocene era, where human beings and their activities are the dominant driving force on the planet. With our success and our progress, however, there have come scars and stains that threaten the future of our planet. On the macro scale, we are contending with geopolitical wars and climate change, but on the micro scale, there are seemingly invisible threats that are looming. Welcome to Future Scout. Today we are breaking down how scientists are breaking down microplastics. Let's kick things off. For those who are unfamiliar with microplastics, it is important to know where they come from. Plastics are made from chemicals called polyethylene terephthalate and high-density polyethylene. These chemicals are highly stable and do not break down chemically within nature very easily, oftentimes taking hundreds or thousands of years. Because of this, you can think of a film of plastic as being something that doesn't biologically degrade the way an orange would if left on the ground. Instead of disintegrating, the plastics simply shed, getting smaller and smaller and smaller while retaining their chemical composition. This is startling because while seeing a plastic bottle or wrapper on the ground is problematic, the larger issue is that it will inevitably degrade to a point of being microscopic, yet still pose a problem. A polymer fragment from these plastics can be as small as 1/25,000th of an inch. They are completely imperceptible to the human eye, and we have no way of knowing where they are in the natural world around us without sensitive instruments. These polymer fragments are so small, they have even been detected in raindrops because the water itself is larger than the microplastics and are thus able to carry them. Areas of planet Earth that humans do not even interact with have had microplastics discovered there. In 2022, for the first time ever, scientists discovered microplastics in freshly fallen snow in Antarctica. Another shocking find is at Point Nemo, which is the furthest place from any landmass on all of Earth. Point Nemo is in the Pacific Ocean between South America, Antarctica, and New Zealand. To provide some context on exactly how far away from land this is, if the International Space Station is flying above Point Nemo in space, astronauts are closer to it than it is to any person on Earth. If microplastics are found here, you can be assured that they are virtually everywhere. It's not just in the oceans though. Microplastics are being found within living organisms as well, in living organisms' blood, feces, and even in the air. At this point, virtually every human has them in their body, and they are even found in the placenta of postpartum women. This is incredibly problematic because the effects of microplastic accumulation are not yet known over the long term. What's worse is how embedded plastic is in the global supply chain. When you think of a water bottle, you usually think of a plastic one or a vacuum-insulated metal one. The problem with plastic bottles is that a single plastic bottle contains an average of 240,000 plastic particles floating within it. This means that for roughly every 4 plastic bottles of water consumed, you likely have consumed around 1 million micro and nanoplastic particles within your body. A scary thought, to be sure. So how are scientists attempting to put a stop to these particles from wreaking havoc on the Earth and on us? Solutions are coming from unexpected places and having unexpected results as well. Dr. Federica Bertoncini, a Spanish biologist who moonlights as a beekeeper, was cleaning out her hives one day while noting that hive-damaging worms were consuming beeswax. To remove the worms, she tossed them into a plastic bag and after revisiting them, discovered that there were holes in the bag. Not only were the worms eating their way out, but they were also breaking down the bags by eating them. These Galeria melanella larvae are called waxworms, and they can eat polyethylene and chemically dissolve it at astounding rates. This is wonderful use for landfills and other large plastic reserves. If you have a large deposit of plastic, you can simply dump a bucket of waxworms on them and they will digest it with a bit of time. How does this happen though? Beeswax and plastic have one similar property that enables the waxworm to digest them both. They both are composed of carbon chains, which the worms are biologically able to digest. While the thought of unleashing worms on the world's plastic problems sounds a bit impractical, scientists have another idea. Dr. Bertoncini suggests that the enzymes in the worm's guts can be used strategically. These enzymes are called phenyl oxidase, and the thought process is to harvest this enzyme to break down plastics on an industrial scale. Eventually, this could be scaled to at-home kits or recycling processing plants to break down the plastic into natural components. This is called biorecycling and can be used to produce new resources from waste materials. This is a promising beginning to using these waxworms. Rather than worms though, let's shift gears and think of a scoop of vanilla ice cream. Aside from the milk and the sugar, vanilla gives it its flavor. But where does the vanilla come from? Vanillin is a versatile chemical that is used to flavor foods. It is also found in the cosmetics industry and a bulk chemical to make pharmaceuticals as well as cleaning products and herbicides. Global demand for vanillin is increasing as well. This is good news because by manipulating E. coli bacteria, scientists were able to convert plastic into vanillin. This means plastics could be precursors for highly valuable substances such as vanillin, and the key to unlocking these chemical value chains lie in microscopic bacteria such as E. coli. Chemistry is the reason plastic is so prevalent, and chemistry is the solution that will ultimately help humans solve this crisis to begin with. Wastewater and drinking water treatment systems are examples of this, and are some of the most effective small-scale solutions to effectively remove more than 90% of microplastics from wastewater and drinking water. There are more practical, visible solutions as well, such as the Cora ball, which is an oddly shaped recycled plastic ball. This ball goes into the washing machine and captures roughly 1/4 of all sewer-bound microplastics. At the Polymer Research Institute of Szechuan University, researchers have developed a robofish designed to collect microplastics as it swims by absorbing them into the robot's soft body. Yu-Yon Wang, the researcher at the university who led the study, designed this small fish to be only 13 millimeters long to help it move through water the same way that plankton drift in the water. Soft microscopic robots are incredible innovations to tackle the plastic problem plaguing the oceans. Some people, like Philip Democritou, who leads the Nanoscience and Advanced Materials Research Center at Rutgers University, is taking a different, substitutive approach. Democritou believes that the model of the chemical industry is to make chemicals, put them out into the world, and clean the mess up 20 to 30 years later when side effects begin to show up. He criticizes this as being highly irresponsible and unsustainable. His approach is to stop using plastics and begin using a plant-based spray coating which he invented that can serve as an environmentally friendly alternative to foods wrapped in plastic. Not only can this starch-based spray protect foods, but can also help prevent damage from transportation even better than plastic as well. When you begin seeing how large the problem is and how many different ways and angles there are to tackle it, it becomes obvious exactly how severe it is. With this in mind, it's incredibly important to realize that not only is it us humans that these plastics affect, but the entire global ecosystem. If we are living without noticeable harm from thousands or millions of microplastic bits inside of our own bodies, can the same be said for smaller creatures such as plankton, earthworms, or small insects? The quantities needed to harm a much smaller organism are significantly less than for humans. Smaller, microscopic organisms consuming plastics could lead to catastrophic consequences such as a bottoms-up ecosystem collapse where the food chain is heavily disrupted due to the disappearance or population reduction of a critical organism. There are profound implications to this, and because it affects everyone needs to be aware. Scientists are lobbying for bans as well as regulatory boards such as the European Environmental Bureau, or EEB, though the situation is already at a level that most would consider to be completely out of control. Companies don't necessarily want to play ball either, and notably so. Plastics have become an enormous industry in packaging and are used virtually everywhere. But where did they come from? World War II necessitated a plastic industry expansion. The need to preserve food, scarce natural resources, and to sustain produce across the Pacific became a high priority during the war. A boom in plastic demand followed the war into the 1960s and 70s, meaning that supply chains could expand because of plastic's cheap, versatile, and sterile nature. Chemical companies such as Dow Chemical, BASF, ExxonMobil, Amcor, and many others have largely contributed to the widespread plastics that we encounter in our day-to-day lives. It's hard to directly blame any individual in these companies because it's highly likely that no one knew how big of a problem microplastics would eventually become. One option is taxing any company producing plastics and using the revenue from that tax to fund research for sustainable solutions to this problem. One thing's for certain. We as a society need to come together to help tackle the existential crisis of microplastics before we hit an irreparable cliff. Thank you for watching Future Scout. Don't forget to like, comment, and subscribe so the team can continue to bring you more videos like this directly to your YouTube feed.